In this lesson, we're going to learn how to write balanced chemical equations. Here are a step-by-step general guideline to assist you with this. First, determine the correct formula for reactants and products. Then write the skeleton equation. 3, determine the number of atoms of each element. You can count polyatomic ions as a single unit if it appears unchanged on both sides. Then you're going to balance elements one at a time using the coefficients. We never balance the equation by changing subscripts because that changes the type of compound or molecule that you have and not the quantity. Check each atom or polyatomic ion to be sure they are equal on both sides, and then check your coefficients that they're the lowest possible ratio. I have a smaller one of these. This particular example, I asked you to write in your notebook page top of 89. I have a smaller list right here for us to follow, so you can watch as I go through these, and I'll tell you when I'm doing which particular step. I'll get a color you can see better. Alright, here's the example. Again, this should be on the top of page 89, and you should have this sentence written. Iron, metal, and chlorine gas react to form solid iron 3 chloride. So number one tells me to determine the correct formula for reactants and products. That is what I need to do first. I had to take a look here. It says iron, metal. It's going to be alone. The symbol for iron is Fe. This and word usually indicates that we need to add something. So we have iron, metal, and chlorine gas. Chlorine symbol is Cl. But here, keep in mind that this is diatomic. Therefore, if it says chlorine gas, I need an added 2 there, because chlorine never comes as a single element like iron will. The next word, react to form, is one way to tell you to draw your arrow to separate your reactants from your products. So here are the reactants. Now we're going to form iron 3 chloride. I have some Roman numerals. There's no and in between these. Therefore, this is one thing. If I take a look, I have a metal and a non. Therefore, this is going to be ionic. The best way to deal with these is not to try to do something in this area right here, but to create your ionic compound separately and then place it into your formula. We already looked at how to make ionic compounds. Iron 3, the Roman numerals tells me the charge, so I know it's 3, and iron is a metal, therefore it's going to form a cation, so it's going to have a 3+ charge. Chloride was chlorine. It is a halogen. It's in group 7A. It is a non-metal. It has 7 valence electrons, and it's going to gain 1 electron to achieve an octet, giving it a -1 charge. Now at this point, I can do crisscross or least common multiple. So crisscross, I'm going to take the digit of the charge and make it the subscript for the other ion, the digit of the charge and the subscript of the other ion. So my formula becomes Fe, and this is a 1 because it's from the chlorine, the digit. So I'm going to have 1 iron, therefore I'm not going to write that because it's understood. And there's 3 chlorine ions in that compound. And I've just done step 1 as well as 2. So I have the correct formulas and I've written the skeleton equation. This right here is the skeleton because it's not balanced, or it's just formulas. All right, it's not balanced. We're going to move on to step number 3. It says determine the number of atoms of each element. We're going to count polyatomic ions as a single unit if it appears unchanged on both sides. So if I look at these, I don't have any polyatomic ions, so I'm not going to do that step. This is the product side on the right side. Here it says determine the number of atoms of each element. I need to take a look and make a list for reactants and then compare it to the list of products. I'm going to move this over. The best way to do this is to take a look here at the order and just write down what you have. I have iron and chlorine. On this side, even though this is a bad example because it is in the same order, keep your elements in the same row. Keep your elements in the same row. If the order on the product side is different, don't pay attention to that. Keep your elements in the same row. It's just easier on your brain. All right. I have 1 iron and I have 2 chlorine atoms. Right? There's no subscript. Here's a subscript. Over here, there's no subscript written to the right of iron, so there's 1 and there's 3 over here. And the next step tells me to balance elements one at a time using coefficients. These blank spots that I've left in front or space for the coefficients, and it changes the quantity of the Fe, it changes how many Cl2s that I have. If I change my subscripts, I'm changing the actual compound, and that is not what I want to do. I would also suggest to not erase these numbers, but to cross them out as you change coefficients. Right now all the coefficients are 1. I'm going to take a look here. Right. So I have my irons are balanced on both sides. I have 1 iron on the reactant side and 1 on the product side. But for my chlorines, I have a 2 and a 3. As I'll show you in a second, one of the best ways to deal with this odd even situation is to make this one even. Now if I put a 2 here in front of the Fe, what that means is now I have 2 of these ionic compounds. So the 2 here says I have 2 of them. Originally I had 1. So if I put a 2 here, I'm going to multiply this 2 times 3, or if you take a look here, you're adding, and now I have 6 chlorines. But because I've doubled this ionic compound, so that's all I can actually do to balance things, I've also changed the number of Fe's. I no longer have 1, I now have 2. So I just cross out original or previous tallies and then change or write next to it what I have now. It's a lot simpler. Trust me on that, please. So if I take a look, I'm only going to deal with 1 element at a time. So if I go over here, I now have a 2 to 1 issue. So I'm going to add a 2 in front of this Fe, and there's a 1 understood here. I now have 2 here, and I have a 6 to a 2. So if I look here at the Cl, I have to figure out how many Cl2s I need in order to get 6 total chlorine atoms. So in order to do that, there's 2, 4, 6. So I need 1, 2, 3 chlorine diatomic molecules to get 6 total chlorine atoms. So Fe, both have 2, so I'm good. Cl and Cl both have 6. I have crossed that out. Therefore, I'm also good. I take a look at my coefficients. I cannot simplify those without getting a fraction. So this equation is now balanced.